Thorben, hi.
Hi, thanks for
Hi.
having me.
Thank you for joining. Kiev is on the line. How are you doing?
I'm good. How are you?
I'm awesome. We are happy to have this event happening, first of all, and we are super honored that you joined our conference this year.
Yeah, it's my pleasure.
I know that you are an author of the best-selling books, and maybe you can share your plans. Maybe you will have another book ready soon.
Yeah, I wrote the book that you can see here in the background, Hibernate
Yeah.
Tips, which is basically a cookbook that shows you how to solve certain Hibernate issues and implement mappings and stuff like that. Um, right now, I'm not working on a new book, but actually today I'm launching a tool, a library that you can add to Hibernate to find performance issues and to get detailed information on how to solve them and avoid them in your code. So that is my next big project I'm launching and working on. And then we will see. I will probably work on new courses and or books within the next year. Yeah.
Wow, thank you for
But for now,
sharing
the
with
focus
us.
is on the tool.
It's a big news.
Yeah.
Thank you for sharing.
Yeah.
I know that we are going to have an interactive session. So you will have a presentation, and we encourage people to post questions in the chat under our broadcast. So every time the question will come up, I will just raise a hand and will ask you a question and will interrupt your presentation. Okay?
Yeah. Yeah. Sounds great. Yeah. Everyone, if you have a question, post them at any time. I will show you a bunch of examples, and it's way easier if we talk about your question while we are still in the example or just moved on for a few seconds compared to discussing all the questions in the end when we then start to figure out to which actual code sample that I showed 30 minutes before you actually wanted to ask your question. So the sooner and earlier we can start discussing the question, the better. Okay, should I start?
Sure, go ahead.
Okay, yeah, then welcome everyone to my talk, Cause of Death, Hibernate. Already got an amazing introduction, so I will keep this part here short. If you want to reach out to me after this talk to discuss questions or to learn more about Hibernate, feel free to reach me on the social channels that you can see in the upper right-hand corner, or visit me on my site, thoughtsonjava.org or torbenjanssen.com, both domains linked to the same blog. Yeah, before we get into the examples, I want to make one thing absolutely clear. You can, of course, use Hibernate to implement highly efficient and scalable persistence layers. I mean, that's what I'm doing in my day-to-day work, where I help teams to improve the performance of their persistence layer and to build a complex and scalable mapping. But, well, let's be honest, just talking about best practices and repeating the same stuff over and over again gets a little bit boring. So why not take a different approach? Why not break a few things today and have a little bit more fun with it? So first question is, well, what is actually the best way to make a project fail with Hibernate? Bad performance, and I mean really bad performance, is always a great way to get a project into trouble and to ruin the user experience with it. Inconsistent results is something that no user wants to see, so that's also a great candidate. And data loss is something that keeps your managers and CEOs up at night because they're worrying about these kind of things. So why not give that a try as well? First thing I want to do is I want to show you how to get a really bad performance. Or if you don't like to break things, well, then maybe focus a little bit more on the second part of each example where I show you what would actually be the better way to implement the whole thing and avoid the problem. So let's start with the classic. Here we have a simple Hibernate transaction. Close that for now. Simple Hibernate transaction, that would be the call in your backend. I fetch an author from the database, return it to the client, and there I try to access the association between the author and the book. So we have a typical online bookstore example here. And you already saw that popping up here. This call down here fails. It fails with the lazy initialization exception. I'm pretty sure everyone who has used Hibernate in a project saw at least a few of these exceptions. These happen quite often, especially when you're sending your entity objects to the client. And if you Google for a solution to the lazy initialization exception, you unfortunately find a lot of bad advice online. One of the most common ones is, yeah, simple fix, just switch the fetch type to eager. Well, let's do that here. Now I'm on the author entity, and on the many-to-many association, I tell Hibernate to eagerly fetch the association. And sure, that fixes the lazy initialization exception because we no longer have lazy fetching. We are now using eager fetching. But even though that might look totally fine in this use case, where I used the entity manager find method to get an author, I mean, here we have an efficient query that gets the author together with the associated books by joining the author with the association table, with the book table. So that might look like a good solution for this case. You see the issue when we are running this test case here. So what I'm doing here, I'm selecting all authors from the database using a simple query, and then I'm writing a log message for each of them, printing out the first name and last name. We have one query, but if we take a look at the Hibernate statistics, then we see we have 7 JDBC statements, and up here you can see why. We have a bunch of statements that get the next books or the next set of books from the database. Why do we have 7 statements here? Well, the first query, our query that got the author, which I had in the code, returned 6 authors. That's the number of authors that I added to my small test database. And after that, Hibernate eagerly initialized the association to the books. So we have a query for each author to get the books. So in the end, we end up with 7 JDBC statements. This is not only a very inefficient approach to actually get the author with their books, it's actually also totally unnecessary, because I'm not using any books in this test case. So by changing our fetch type from lazy to eager, we actually replaced the lazy initialization exception, which we easily found in our test case, with a performance issue that will probably show up in production, because these 6 additional statements that we have here will not cause any issues on our test system. But if we deploy that to production and we select a few 100,000 authors, then we execute a few 100,000 additional queries, and that for sure will cause a performance issue. So let's go back to the author entity, remove the fetch type eager here, because that was a really bad idea, and try a different approach. If we now run the same test case again that selects all the authors, then we can see that we now first have one JDBC statement, and that one only selects the author. I mean, we don't need anything else in this use case, right? We're just printing out first name and last name. So this approach is good. But now we need something else up here. And the better way to solve this lazy initialization exception is to use a join fetch clause or a left join fetch clause. What does that do? The join fetch tells Hibernate to initialize the association, this books association here. And you can see that in the select clause, we are now selecting columns from the author table and from the book table, and we have the same join as we had before in the from clause. So here we have basically the same query as we had in the previous example, when we still used fetch type eager and the entity manager find method to get the author from the database. The main difference here is that we are now in control of when we fetch the association from the author to the books. And it's, of course, way better to add such a clause to a use case that actually needs the book association and fetch it only in that case, and don't touch the books association in all the cases, like this one down here, that doesn't need the books. Okay, that was a pretty common issue that most of you hopefully already knew. But now I want to take a look at a different mapping issue that you can use to actually cause performance issues in production. So here I'm doing a very simple thing. I'm fetching a book from the database, and then I'm removing the first author from the list of authors that wrote that book. And when you look at that code, you would probably expect that Hibernate removes the one record from the database, from the book author table. Unfortunately, that's not the case. What Hibernate does here is it removes all the records from the book author table that belong to the book, and then it's inserting the 3 remaining authors. That not only looks very strange when you're writing an audit log for your database, it also is a pretty inefficient approach. So the question is, why did that happen? Well, that happened because I modeled the many-to-many association as a Java util list. And while this might be a great idea when we are working on a plain Java application, it is actually a bad idea when working with Hibernate. Because, well, as you saw, the handling of the association in a write operation wasn't that great. You can easily fix that by replacing the type of your attribute with a set instead of a list. So I changed that here. And when I now run the same test case and open up the log output, then we can see that Hibernate now removed exactly that one record from the association table that we removed in our business code. So this approach is way better than the handling that we saw before. Let me quickly switch that back to a list, because that's something else that I want to show you. Using a set has another benefit. So in the first example, I showed you that a left join fetch clause is a great approach to initialize an association that is lazily fetched for all the use cases in which you need it. Well, a typical next question then is, okay, what do I do if I have multiple associations? So let's say I want to fetch a book from the database and I need the authors and the reviews of that book. Well, you could use 2 left join fetch clauses, but as you can see here, that causes a multiple bag fetch exception. What's that? What is a bag? I mean, let's take a look at the book class. There is no bag. There are only lists. A bag is a Hibernate internal data type that is used for an unordered collection. So as long as you don't add any ordering to these lists are actually mapped as the conceptual type of a bag. And Hibernate can fetch multiple of them. If you want to avoid the multiple bag fetch exception, you would need to change the data type here to set as we did before. And I'm now doing that for both associations, for the author and the reviews association. And then we can run the same test case again. Okay, no multiple bag fetch exception. Got everything that we need within one statement. But when we're talking about multiple join fetch clauses, we also need to talk about the downside of this approach, because it's not really a great solution for all of your use cases. There are some people out there who say never use more than one join fetch clause. I don't agree with this kind of blanket statement, because that would mean that we treat an association with 2 elements in the same way as an association with 100,000. And I'm pretty sure we all agree that it makes a difference if we are fetching 2 or 100,000 records, right? So when you're using multiple join fetch clauses, you need to be aware that Hibernate joins all of them in the from clause and selects all of the columns in the select clause. And when you're joining these down here, then you're creating a product. So if you're joining the books with the authors, then you get the information of a book with all the information of the first author, then the information of the same book with all the information of the second author, and so on. That's a typical situation with SQL and relational databases. So using this approach here with multiple join fetch clauses, you need to be aware that you're at the risk of creating a huge product. And that's especially the case here when we are joining the reviews. If you're looking at a common bookstore and at the latest best-selling book, then you will probably see that there are hundreds or even thousands of reviews for that book. And joining them might become an issue. So please be a little bit careful with using multiple join fetch clauses here. But in general, using a set and using the join fetches on smaller associations, this is a really great approach. If the associations are too big so that the product gets too huge to get created in your database, or too big to transfer it over the network, then you would need to split up this query here. But there's actually a better approach that you could use to get the information from the database. So what I wanted to do here was I just wanted to get the title of the book. Then I want to get a comma-separated list of the names of the author and the number of reviews. Well, for this information, we don't actually need to fetch this graph of entities with books and reviews and authors. We could also just fetch the information that we need, and that's what I'm doing here. So here I'm selecting the title of the book, then I'm using a database function to aggregate the author names, and then I'm counting the books. And right, to make that a little bit easier to handle, I'm telling Hibernate to instantiate a book author review object for each record in the result set. So I want to call this constructor here. How do I do that? Well, you can use JPQL and this constructor expression, which starts with the keyword new and then the fully qualified class name, and then the parameters that you want to provide to the constructor, the title, the comma-separated list of names, and the number of reviews. So using this approach, Hibernate, and we can see that in the log in a few seconds, Hibernate only selects the columns that we need and returns them as an unmanaged object. So this is not an entity object, this is a plain Java object, and Hibernate immediately forgets about it after it returned it to our business code. So you can see here that we only select the information that we actually need. So this approach would be even better than the one that we used before with two left join fetch clauses and multiple sets. Okay, next thing I want to do is I want to take a quick look at caching, especially at query caching. With Hibernate, you can use three different kinds of caches. The first level cache is always used for all the entities that you fetched within your current transaction. Then we have the second level cache, which is entity cache that is shared by multiple parallel sessions and transactions. And then we have the query cache, which is Hibernate specific, which caches query results. And this is the only one that's actually used when you're executing a JPQL query. So you might say, well, then we are using the query cache to, for example, here, get a book from the database with initialized list of authors and of the reviews. We tell Hibernate to activate the cache for it. And if we then have a second transaction down here, which executes exactly the same query with activated caching, then we should get all the information from the database in the second iteration, right? I mean, it's told Hibernate to cache it. Well, let's take a look at the log output. No. We made the situation even worse. Instead of executing the query that we have in our code, we now executed 36 JDBC statements. Why did we execute 36 statements? Well, if we look at the log output here, we can see that we selected the reviews for a book, the authors for a book, the reviews for a book, the authors for a book. But I'm pretty sure you know how this is continuing, right? So here we still have lots of statements that fetch the books and the reviews, the authors and the reviews. So why did we fetch the authors and the reviews, which we fetched joined up here? Well, scroll a little bit up, we can see that we are not only selecting the authors and the reviews, we are also selecting the entities of the book entities somewhere here. We're also selecting the book entities in the second iteration. And there's a reason for that. And the reason for that is how the query cache works. The query cache caches query results. But if these query results are entities, then it just caches a reference to the entity. And in the next step, when Hibernate gets the result from the query cache, it tries to resolve the entity reference against the first level cache. And if it's not in there, then against the second level cache. Where we started a new transaction here and we've got a new entity manager. So we didn't fetch any entities within our current transaction. The first level cache is empty. We don't have any entities in there. So the next question is, did we cache the book entity? No, we didn't. See here, the cacheable annotation was commented out on the on the book entity and also on the author entity. So I add them again. So now, let's take another look at the review. The review is cached. Okay, so now the book, the author, and the review are cached. Should be better now, right? So let's take a look at the log output. On the same test case again. And we can see that we have 24 statements. Well, that's better than the approach that we had before, but we actually wanted to get all the data from the cache. So what's going on here? Well, we still fetch the reviews and the authors from the database. And the reviews and the authors. So let's go to the beginning and see what's up with the books. Okay, here we start the second iteration and we can see that we immediately fetch the authors and the reviews. So we actually got the books from the database, from the cache. These are these 13 hits that we have here. So one step closer, but still not there. So what's going on here? Well, when you annotate when you activate the caching for your entity class, then Hibernate caches that entity object that you got from the database. What it didn't cache in this example was the association between the authors and the books and the reviews. And to do that, we need to annotate the association elements, here the authors and the reviews, with Hibernate's cache annotation and tell Hibernate that we also want to cache the association between these objects. So let's run the same test case again, jump into the log, and now we can see we got 43 objects from the cache and we executed 0 JDBC statements. Yeah, no statements, no queries, got everything from the cache. We finally managed it to not only cache this statement here, but also to cache all the elements of the result set. So all the things that were returned by that query. So as you can see, caching is a two-edged sword. You need to be really familiar with how Hibernate's caches work, and you need to know about these pitfalls. And even if you're familiar, please make sure to configure your log correctly for development settings and to activate the Hibernate statistics. You can find a detailed article about that on my blog, so that you actually get all these information that you saw here, the statistics, the SQA statements, and so on, so you can really understand what's going on internally and make sure that Hibernate doesn't act like a black box. Because if it's a black box to you, then it's because you didn't configure your logging correctly for the development environment. Okay, I want to show you another thing with a query cache and how you can use it. I said before that these unmanaged objects, these DTO objects, are great for read operations because they enable you to fetch only the information that you need. You probably remember this part here, the book author review object that I want to instantiate for each record in the result set, to which I provide the title, an aggregated string of the author names, and the number of reviews, right? That's the one that we used just a few minutes ago. So let's cache this query that fetches the book author review. But the great thing about this is that you can actually cache these DTO projections with such a query. So here you can see the query that I just executed. We selected the title of the book, the names of the authors, and the number of reviews. And you can see here that we put them into the cache. And in the second iteration, we have 0 JDBC statements, and we have 1 hit on the query cache. And we got back a list of, you can see that up here, book author review objects. So this is the best approach to actually cache DTO projections, and your only approach with Hibernate. The only alternative would be to implement a business level cache for that. So before we go on, I want to take a minute to talk about the query cache and when or how you could use it. So as I said, it's an option that you can use to cache the result of an actual JPQL or criteria statement that you executed. But when you're using it, you need to be aware that the query cache gets invalidated relatively often, and that it only works well for your overall performance if you execute the same query statement often enough with the same bind parameter values. Otherwise, the query cache isn't used because if you execute the same query, let's say you try to select an author by its primary key, it makes a huge difference if you're selecting the author with ID 1 or the author with ID 2, right? So first of all, make sure that you execute the same query with the same bind parameter values over and over again. The next thing you need to be aware of is that Hibernate doesn't know which records are actually affected or returned by this query. So when you change anything on the underlying database tables, let's say in this case on the book table, then Hibernate doesn't know which cached query results are actually affected by that write operations. And because of that, Hibernate invalidates your query cache whenever you change anything on the tables that are referenced in that query. So in this case, that would mean as soon as you change or add any record on the book table, on the authors table, or on the reviews table, this cache query result will get invalidated, and you will need to execute it again so that Hibernate can add the updated values to the cache. Okay. That's all about bad performance for now. So as I said at the beginning, bad performance is one of the common reasons why projects fail. And with Hibernate, it's actually pretty easy to create bad performance, unfortunately. So what should you do instead? As I explained, try to avoid fetch type eager and use fetch type lazy instead. And please be aware that fetch type eager is the default for all to one associations. And then when you're using fetch type lazy, you need to avoid the lazy initialization exception, and you can also cause n+1 select issues by lazy fetching. To avoid all of that, you can use case specific fetching, like the join fetch clauses that we used, or a use case specific DTO projection. And then we talked about the correct data type for many-to-many associations, and that would be the Java util set instead of the Java util list to avoid inefficient write operations. You should be careful about cascade type remove. It creates a very bad performance, but it can also cause data loss, which is something that we will talk about at the end of this talk. And then we talked about the second level cache and the query cache, where you need to make sure that the second level cache and the query cache configuration actually fit together, which first of all is that if your query returns entity references, then these entity classes should be cached in the second level cache to avoid additional queries. Otherwise, Hibernate will execute additional queries to resolve the entity references. That also means that you need to make sure that your two caches don't get invalidated at different times, or at least that the query cache results get invalidated before the entities in the second level cache. Okay, the next thing you can do to cause real issues with your project is to produce inconsistent results. That's something that all users hate and that we ourselves probably also had several times in the past. So how can you create inconsistent query results with Hibernate? Let's take a look at this first query here. In the beginning, I said that you should use left join fetch clauses to initialize associations, right? So these are great to tell Hibernate that you not only need the author entity, you also need the association to the books. Whoops. And when you do that, then you have, well, a join to the books already here, right? So why not use it in the where clause? Well, the reason why you shouldn't use it in the where clause is because it produces wrong results. So let's take a look at the log output. Here I have the query that we just wrote with the join fetch clause between the author and the books. And I selected all the authors with an initialized list of books who have written the book with the ID 2. So we can see here that Max Mustermann wrote book 2 and Maria Mustermann wrote also book 2. Well, looks good so far, but there's an issue with that. Let's switch the query, second one, and take another look at it. So here, I'm now using two left join clauses. One simple left join clause, which I then use in my where clause, and a left join fetch clause to initialize the association to the books. And now let's take a look at the log output and the difference. So in the previous test run, Max and Maria both only wrote book 2. Well, that's actually wrong. Maria also wrote book 3 and book 4, and Max also wrote book 1 and 3. So yes, both of them wrote book 2, but it wasn't the only one they've written. Why did the first result cause the mistake that we didn't saw these other 3 books, book 1, 3, and 4? Well, the reason was that we just had one join clause from the author to the book. Now we have 2. We have one from the author to the book, which has the alias book 2, and we use it to create our where clause in which we limit the results to all authors who have written that specific book. And then we have a second join clause here, which is then called book 4, and book 4 is used in the select clause up here. So by using two select clauses, we are able to get all the books written by the author. With the previous approach, where we just had one left join fetch clause that we also used in the where clause, we limited the records in the result set to all the records that have the book ID 2, which was just book 2. So in the whole result set, there were no books that didn't have the ID 2. So when Hibernate used that result set to initialize the list of books of each author, well, then there was just this one book for each of them. But that, as you've seen down there, that's wrong. What's actually necessary is to create another join clause to the books table to get all the books written by these authors. So to have a join to the book table that is not limited by the where clause. And yes, that's something I always get questions about. This second approach with the two join clauses is more complex and is slower than the other one. But just using one join fetch clause is actually wrong. So if you want to get a fully initialized list of books, which you want to do if you're adding a left join fetch clause, you need a second join for your where clause. And if you're using the criteria API, that's actually what's happening and what you're forced to do. Because there we have two different interfaces, one for the join and one for the fetch. In JPQL, this is not the case, and you can use the left join fetch, as I did in the first example, also in the where clause. From my point of view, it would be better if Hibernate throws an exception here and tells us about an invalid query, but unfortunately, that's not the case. Okay, let's take a look at another way to get an inconsistent result. So here I prepared a test case in which I use a JPQL statement to update a huge set of database records. That's way more efficient than fetching all these entities and calling the setter methods on the first and last name attributes, because that would cause Hibernate to create an SQL update statement for each entity. So if we are selecting 100 authors here, and if we are then updating them via their setter methods, Hibernate would trigger 100 SQL update statements. And it's pretty obvious that that would cause a performance issue on a bigger database. So a simple way to avoid that is to write a JPQL update statement in the same way as you would write an SQL update statement and to change the data, right? Well, yes, but when you do that, then you need to be aware of your first level cache and of the side effects that these JPQL update statements can cause. Because up here, I'm fetching all the authors. They are now as entity objects part of my first level cache, which is the persistence context. When I'm now executing this query, then Hibernate doesn't know which entity objects this statement actually affects. Hibernate just generates the SQL update statement and sends it to the database. So these objects that I got up here didn't change. When I now fetch them again after the query, you might expect that you would get the new version from the database. Unfortunately, that's not the case. You can see down here, the names are still not in uppercase, even though we executed the select statement here. What happened? Well, when Hibernate processes this statement here, Hibernate iterates through the result set, sees, okay, these are entity references, and for each reference, it checks if that object is already part of the first level cache. They are all part of the first level cache because we added them up here, and that means that we are not having any objects, new objects from this statement here, because then Hibernate just gets the object from the first level cache, returns it, and ignores the record in the result set. So if we want to get the updated data down here, we first need to clear the first level cache. Please always do that together with a flush. Otherwise, you will lose all pending write operations. And then we see that now all names are in uppercase. Okay, another thing that I want to show you is the handling of bidirectional associations. Bidirectional associations are tricky. They are very easy to use in your business code. At least it always looks like that. But you also need to make sure that you always update both ends of it. So let's create the worst case first. So here I have a bidirectional association, and the author entity models the referencing side. It references the defined associations on the book entity. So when I now get two objects, an author and a book, and say, well, it was actually a mistake, the author didn't write that book. So I removed the book from the list of books of that author. Then we would expect that, first of all, down here, our lists are updated. So the author is no longer a list of the authors of that book, and that book is not in the list of books of that author. But as you can see here, that's not the case. We only updated the author. So book one is no longer part of the list of books of the author. But the book still thinks that it was written by Max Mustermann. So until the end of our transaction, we now have an inconsistent state here. It gets even worse. We see a select statement here, another select, even more selects, but no delete statements. The association record was not removed from the database because we only removed it in the from the referencing side. What we need to do to trigger the remove operation and to make sure that both objects, the author and the book, are in sync is we need to update both ends of the association. So I now remove the author from the book, from the list of authors on the book, and the book from the list of books on the author. And because of that, we now have an author and a book entity object that are in sync, and we have a delete statement down here. So writing these two statements all the time is actually pretty error prone. Sooner or later, someone will forget about it. And that's why I recommend to add these utility methods to your entity classes, which actually do exactly the same as we did before. But now we can call the remove author or the add author method in our business code, and we get all the operations done that we need. So then another thing that I want to quickly talk about is the open session in view anti-pattern. It's used by it's used by default by string boot, and that is actually a bad thing. Wait a second. I broke my test case here. Yes. Grouped by A. Okay. So what we want to do here is we want to select the author and count the number of books written by that author. What did I do? And you must appear in the goodbye clause. Okay, so I'm selecting the author and count the number of books in my counting the number of books in my select statement. And unfortunately, I somehow broke the statement here. Let me quickly.
Thorben, can I interrupt you?
Yeah, please do.
Yeah, we have a question in the chat.
Yeah.
The question is, could you comment the difference with using JPA repository methods instead of direct Hibernate implementation?
Well, actually, the repository just provides you a small usability layer on top of Hibernate and provides you a bunch of standard implementations that makes your life as a developer much easier. So when you're using Spring Data JPA with JPA repositories, then, well, on one hand, you're using a best practice, a repository pattern, which is a good thing. And you save yourself the work to write some boilerplate code. But in the end, you're still using Hibernate and all the APIs that Hibernate is internally using. So you still need to be aware of all the mapping information. And you, of course, can use all features provided by Hibernate. You can add your own repository methods to the Spring Data standard repositories. And within them, you can use the entity manager and write whatever kind of Hibernate code you want to write. So in general, I would recommend use the, if you're working with Spring, of course, use the standard JPA repository methods provided by Spring. They're great, but don't think you're limited by them. You can extend it in any way you want. I hope that answers the question. If not, then please ask it again and point me to the part that I missed in my answer. Okay, I actually fixed my query. So I'm selecting the author and I'm counting the number of books. And then I'm opening the entity manager, I'm selecting the authors and counting the number of books. Then I'm committing the transaction. That is the end of my my business layer. And then in the view layer, the entity manager is still open. That's the key element of the open session in view pattern. So the idea there is that you open the entity manager in your view layer before you enter your business code. Then you execute all the business code, including the transaction start and commit. And after that, your entity manager is still open and you can initialize your, in this case, books association, even though your business code finished the use case. And you don't get a lazy initialization exception as we did in the beginning of this talk, because here the entity manager is still open, but it doesn't have the same transaction running as you used for your business code. And that causes multiple issues. First of all, Hibernate now needs to open a new transaction when you fetch the books association down here, which increases the load on the database. And starting and committing transactions is actually pretty expensive on the database because it has to write logs and all these kind of things. But it also creates the risk that your result might look inconsistent if you have multiple transactions running in parallel. So here I use the data returned by my business code to write this log message in which I say that Max Mustermann wrote 3 books. These are book 2, book 3. That is the log message that I wrote based on the lazily initialized books association. As you can see, these are 2 books, not 3. Why is that the case? Well, because we had a parallel transaction here that actually removed a book from the list of books of that author. So the better approach would be to, up here, not only select the author and count the books, but to also get the list of books, which we then use down here, and basically have a projection in our business code and query that matches the use case. So we need to know that the front end requires the list of books of that author, and we need to fetch them up here so that we don't need the open session in view anti-pattern, and can be sure that the information that we get here and that we showed down here in our very basic view layer consisting of 2 log messages actually fit together. Okay, so how can you avoid inconsistent results? Let's summarize this last part really quick. First of all, when you're using join fetch clauses, please make sure that if you want to use them in the where clause, you also need a join clause for that. Don't reuse the join fetch association in your where clause. That will reside in an incomplete list of associated entities and can cause severe issues. In worst case, even data loss. Then you need to be always aware of your caches, especially if you are executing JPQL or criteria update statements or remove statements. You need to initialize or update all of your bidirectional associations on both ends, and please never use the open session in view anti-pattern. Okay, let's lose some data before we end this talk and go to more questions afterwards. So what can you do? Well, the first thing you can do is you can use Entity Manager Clear, as I explained before, that that was the one that we used after the JPQL update statement without doing a flush. So here I'm simulating a small batch job. So I'm selecting all books from the database. I'm selecting them in batches of 5, and then iterating through the list of books and changing the title to uppercase. And if this would be a huge batch job that processes several thousand records, we would get into the situation that managing all these book entities in our first level cache would actually slow down our application. So a typical approach there is that you add a clear to remove the records from the database, from the first level cache. But when you do that, you need to make sure that you flush them before, because otherwise this will happen. You can see that the book 1 to 10 are still not in uppercase, just book 11 and 12. And the reason for that is that we cleared the cache every 5 records without flushing it, which basically means Hibernate removes the record from the first level cache, but doesn't check if these entities are dirty. With an additional flush, you can see now all of them are uppercase. Another thing, and that's the final thing that I want to show you, is the risk of using cascading. So here I have an author. Let's activate cascade type all on the association to the books. And do the same here on the books association. So when we are removing an author, we also want to remove all of his or her books. And if we are removing a book, we also want to remove the corresponding author. Well, that is a pretty risky setting, because as you will see, that's the remove operation bounce back and forth between the book and the author table. And if you now have a situation like the one that I created here, where multiple authors have written books together and books on their own, and they have had multiple collaborations with different authors, that quickly adds up into a situation where we don't have any books. So you can see here, there's no log message afterwards. The book table is empty because our delete statement bounced back and forth between book and author, because we cascaded the remove operation. You might now say, well, sure, it's a typical misconfiguration. You can't add cascading on both ends of the association.
Thorben, sorry, we are running out of time. You have a couple of minutes left, and also we have a, I would say, use case rather than question in the chat, so I can read the use case and get your answer, and we will end with your talk, and I will invite you in the Q&A, and guys can continue to ask the questions.
Yeah,
okay?
just give me 30 seconds, then I will be done with this thing here. So what I did now is I removed the cascading from the books association, from the author associations on the book. And if we now take a look at the books written by the author 2, then we see that author 2 wrote book 3, 4, and 2, and it wrote book 1 and book 2 together with author 1, which we remove. And if we now remove author 1, then we see that the author 2 only wrote book 4. The 2 other books that this author wrote together with author 1 got removed because of the cascading. So in these situations, cascade type remove deletes more records than you expected, and you should only use it for parent-child associations, and these are almost never many-to-many associations. These are only many-to-one associations. Yeah, that's it from my side. I'm now happy to answer questions. If you want to learn more about the tool that I mentioned at the beginning of this talk, then please check out torbenjanssen.com/perftester. And now I'm happy to take questions.
Okay, thank you very much for your perfect presentation. And we actually have a use case, as I said, from Frayne in the chat. So I will read it, and we hope for your beautiful answer. So one problem that occurred in our use case is also using the map struct, where to add proper mapping, we again utilized Entity Manager. That is the part which causes many problems with removing eager relationships in our projects. I read all of your best practices, and in one of them you said that relationships are only a feature, not a must-have. So I would like your advice about maintaining your own FK relationship versus establishing relations in entity code.
Yeah. So if I understand the situation correctly, then the issues are caused by the additional usage of the map struct mapper. And first of all, I would dive deeper into that part and make sure that you only map the associations to your different data structure if you really need it. And by default, you shouldn't map them. You should just remove the association part from the map struct mapping and just map the basic attributes. That would probably solve most of your issues. Otherwise, yeah, the association between these entity objects becomes an eager association. In general, I would, so now to the other question about the foreign key mapping. In general, I would try to keep an entity association mapping in my domain model because it makes working with Hibernate so much easier. But you can, of course, model foreign keys. That would just be a column of the same type. Well, you would map the foreign key column as a basic attribute on that entity, and then you trigger additional queries whenever you need to fetch the associated entities. As long as you're using Hibernate and as long as you're willing to use its proprietary features, you could even use the foreign key column as a join condition. So that participant already mentioned my blog. So if you're already on the blog, please search for the mapping of unmanaged associations. There you can find the syntax that Hibernate supports to define these join clauses. These are not supported by JPA, so that is a proprietary Hibernate feature. But then you could use the foreign key mappings even in your JPQA statements, and you could basically build your application in a pretty similar way to what you would do when you're using plain SQL. But as I said in the beginning of this answer, I would first try to solve the issue with the mapper and to keep the managed associations because that makes your life way easier than the other approach.
Thank you. Thank you so much. So guys, if you have more questions to Thorben, you just go into the Q&A chat, and Thorben, we are also inviting you to join this Zoom chat so people can ask you more and more questions. And I want to thank you once again for joining us. I hope next year we will meet offline on our conference here in Kiev, and we will welcome the audience also offline. Thank you once again. Have a great day. And hope to
Thanks
see
for
you
having
soon.
me. Have a great day as well. Yeah, and everyone who wants to join the Q&A, I will join the chat as well, and I hope to see you there.
Thank
Have a
you.
great rest of the conference. Bye.